Alright, so let's end this section by telling you about something about non-homogeneous first order linear systems. So it's of the form x prime is equal to p. This p is a matrix, so we both face it of t times x of t plus f of t. This is a vector. And because this is non-homogeneous, this time f is not 0. Alright, so the general solution of this non-homogeneous first-order linear system is of the form x is equal to xc and plus xp. This should look familiar because we have already seen this in chapter 5. So xc is called the complementary solution, which is the solution of the homogeneous part. And homogeneous part means we drop the constant term. So first we drop the constant term, we solve the homogeneous part, we get a complementary solution, and then we get a particular solution. So all we need is one particular solution, which we learned in section 5.5 using the what's called method of undetermined coefficient. This is method of undetermined coefficients, is fancy name for guessing. Okay, so let's look at an example. So let's consider x prime equals to, remember this matrix is the same as the one in the previous video, times x, but this time we have the constant term, so let's say negative 9t plus 13, 7t minus 15, and negative 6t plus 7. Okay, so notice this is same matrix as the previous video. Okay, so because it's the same matrix from a previous example, we actually have already solved the complementary solution. So you can go check the slide. Complementary solution is C1. It's a linear combination of the three vectors we talked about. So it's C1 times 2e to the t, 2e to the t, e to the t, plus C2 times 2e to the 3t, 0, negative e to the 3t, and C3 times 2e to the 5t, negative 2e to the 5t, and e to the 5t. So that's the complementary solution from the previous video, and the particular solution. So if you look at the constant term, so this is the constant term. All the three entries are linear functions, so we can make a guess that xp is a linear function. So we can get at plus b, ct plus d, et plus f. So once we made the guess, we just plug it in the original equation. Because there are 6 variables, it's a little tedious. We're not gonna go through all the linear operations here. If we plug into the original equations and solve for a, b, c, d, e, and f, we get the particular solution is equal to 3t, 5, and 2t. So the numbers turned out to be not as bad as you think. So that's the particular solution. So the general solution is x equals to the complementary solution plus the particular solution. So this is equal to C1 times, let me change the color, C1 times the first vector plus C2 times the second vector plus C3 times third vector. I think I can squeeze it in, and then plus the particular solutions, 3t, 5, 2t. This is a t here. Okay, so that's one way to write our solution. If you want to write it in terms of functions, then the solution looks like the first entry is the sum of all the first entries. So it's first 2c1 e to the t plus 2c2 e to the 3t plus 2c3 e to the 5t. And next 2 is 2c1 e to the t. Nothing's for c2. Oh, I forgot a 3t here. 3t. I'm just going to change the colors. So it's 2c1 e to the t plus 2c2 e to the 3t plus 2c3 e to the 5t and plus 3t. And next 2 is 2c1 e to the t plus minus 2c3 e to the 5t plus 5. And x3 is, there's no 2 here, c1 e to the t minus c2 e to the 3t plus c3 e to the 5t and plus 2t. Yep. And if you do have initial conditions, then you can solve for c1, c2, and c3, but we're going to end the section here.